So, good afternoon, everybody. I know you're very busy with your tasks and projects. I will try to... So my name is Sebastien Ziegler from Monday International. I'm currently coordinating 2 European research projects on the IoT. One is IoT6 and IoT on IPv6, or IPv6 and IPv6 related protocols for the Internet of Things. And the other one is IoT Lab and IoT and crowdsourcing. What I will try to do in what do you have, 1 hour and a half, more or less, is to split my presentation in 2 parts. The first part, which will be more focused on kind of overview of current use of IPv6 in different European research projects and IPv6 perspectives on the Internet of Things. And the second half, we will invite you to play a more active role in relation with the IoT Lab project, and we will ask you or invite you to work in small groups on some use case addressing for the project for crowdsourcing on IoT. And for that, there will be some of my colleagues from IoT Lab who will come later at about 2, I think. So, let me start. Regarding IPv6, we started this project IoT6 about 3 years ago with a consortium of different European partners, academics and industrial partners. So you have Moru International, Ericsson Serbia, Run My Process, which is a startup in the field area of cloud computing, UCL, University of Murcia, Technical University of Vienna. We have a Korean partner, KAIST, who is one of the 2 leading research centers in Korea, and Luxembourg University, and so on. And then we have Industry Advisory Board, which gathers several industrial partners mainly, but not only. We have ETSI, which is a standardization body. We have Philips Lighting, Sunfi, which is a European company in the sector of blinds, SIAT, which is more in the area of HVAC. We have Vincent, who is the father of the Internet Protocol and vice president of Google, Cisco, and some other partners. And we have, of course, a close collaboration in this project with the IPv6 Forum and with Latif Ladid, who is the chair of the IPv6 Forum and who is a member of the project. The objectives of this project were threefold. The first one was to research the potential of IPv6 and IPv6 related standards for the Internet of Things. That's almost obvious. But based on that, the idea was to try to develop a highly scalable, service-oriented architecture, using and exploiting as much as possible the IPv6 features. And then again, based on this second objective, to try to explore innovative forms of interactions with multi-protocol integrations, with mobile phone networks, tags, RFID, with the cloud computing and intelligence distribution. In other words, what we try to do with this project is to see how we could use IPv6 for a horizontal cross-domain integration of the Internet of Things. So enabling more interactions and integration and an easier integration between different subsystems of the IoT, so mobile phones, sensors, tags, and others, and a vertical integration between the Internet of Things, the physical components, and the cloud application, in particular with a focus on the software as a service, and of course interactions with the end users. Why IPv6? There is an obvious answer. I mean, the first obvious answer is related to the capacity of IPv4, which is limited to about 4 billion addresses in total, in theory, but in practice with quite less addresses available. And if you just compare the IPv4 addressing capacity with the human world population, you already have a gap. You don't even have enough addresses to provide each and every human being on Earth with its own IP address for its own use. And then if you compare it to the expected population of IoT components by 2020, which is not the end of the process. It will probably continue to grow beyond this date. You have a clear scalability challenge, a gap between the capacity of IPv4 and the current needs of the IoT environment. I will not dive into the detail. You all know that the IPv6 address is about 4 times, not about, it's 4 times longer, larger than the IPv4 address. which doesn't seem a great revolution, but it paves the way to a certain number of paradigm change in the way we address the Internet of Things. First of all, there's an issue of magnitude. Just for you to realize what it means to have 2 power 128 addresses, it's so about 3.4, 10 power 38 addresses in total. In terms of magnitude, if you move from the current IPv4 address scheme to the human population or even to the IoT device population by 2020, you don't have a big gap. You have a gap of more or less 1 magnitude of difference between the needs or the capacity of IPv4 and the effective need in terms of IoT addressing in a short future. It means that IPv4 has been well designed and well thought, even if when they designed it, they didn't expect to have such an evolution with the internet. But nevertheless, we're not so far with IPv4. So IPv6 is providing quite more addresses. If you take the number of neurons in the brain, so you have about 10 power 11, which is already a little bit more, but not so far from IPv4. If you want to come closer to IPv6, you have to move up in the scalability. You can take the number of square meters on the Earth's surface, already 10 power 14, so it's already a little bit higher. So anyway, IPv4 is overpassed, but IPv6 could easily address each and every square meter on Earth. It could address each and every square millimeter on Earth. Then you are 10 power 20. And still you have a margin to have an idea of the potential, of the power of IPv6. Then you can take the number of grains of sand on the Earth, 10 power 20 about, so again, we can address each and every grain of sand on Earth with an IPv6 address. You can then move a little bit higher, stars in the universe, a current estimation by NASA and other astronomic research institutes is about 10 power 23. So again, we have enough IPv6 address to address each and every grain of sun on Earth and each and every star in the universe, including the stars that we don't see, of course, on the other side of the universe. Then to come closer to it, you need to take the number of atoms in a human body. It's about 10 power 27. And then you take the whole population, the whole humankind, human population, and you have, and with about 10 power 37. Atoms. If you take the whole world population, you could address with IPv6 each and every atom, not molecule, atom of each and every human being on Earth. And then you can do it for 30 generations. So just to give you an idea what is a shift in terms of magnitude by moving from IPv4 to IPv6 in terms of addressing capacity. Then another aspect which is quite interesting with IPv6, which is well known by many of you, that the IPv6 addressing is split in 2 parts mainly. There's one part which is by default reserved for the host ID, and another half which is used by the network, the networking of the routing process of the network ID. It means, in other words, that you can, with the same address, get de facto, even if it was not the aim, you can get de facto an identification of the location of the network of the device and an identification of the device itself. And de facto again, one of the common way to generate dynamically an IPv6 address for a sensor is to use its MAC address. So often you will find the MAC address embedded in the host ID, which is de facto integration between the layer 2 and layer 3. So you have a close integration of the identification of the physical device, not only the node on the network. Some other properties of IPv6. So you have the high scalability, we mentioned it, the fact that we have currently a global deployment of IPv6, and we'll come back later on the stats and the figures regarding IPv6, end-to-end connection, and that's very important. So far, if you would have to run the internet today without the NAT, with IPv4, it wouldn't work. We don't have enough addresses to address each and every node with IPv4 anywhere today, with the existing network. So we started to use NAT intensively, but NAT means that you do not have end-to-end connection with your device. You have a connection with a NAT, and then behind the NAT you have something which pretends to be the things that you want to address. You do not have direct end-to-end connection, which is a big issue in terms of authentication. So it's perceived sometimes as a positive thing for firewalling, because then you can say, oh, I hide my IP address to any foreign person. They don't know what is a real IP address. I can find a way to. But nevertheless, it has two main limitations. You don't have end-to-end connectivity. You cannot then really authenticate the node. You must trust a third party in the middle. And the other element is that you cannot access directly this node from the internet. You can have a sensor which can connect the internet with a volatile address, but you cannot access the sensor directly except if you start to deploy complex gateways or ways to turn around. Stateless address auto-configuration, that's another aspect which is interesting with IPv6. The possibility for any node to configure itself, to define its own permanent IP address on the network. You don't need to have someone to start configuring the address manually. Strong security enablers like IPsec and others. The fact that IPv6 has been, over the years, optimized with different standards and protocols to be adapted to constrained devices. So you have 6LoWPAN, you have CoAP is closely related. The development of CoAP is closely related to 6LoWPAN. You have currently very light stacks like Contiki and others, which enables you to run your mods with an IPv6 or 6LoWPAN addressing scheme, which is naturally and directly integrated into an IPv6 network. Then you have mobility with Manemo and the different solutions which have been developed to handle and address the mobility of your nodes in an IPv6 network. And you have a solution which is a networking scheme which is fully internet compliant, which would not be the case with ZigBee, Z-Wave, or other communication standards for the Internet of Things. Regarding the effective evolution of IPv6, because one of the critics we speak about IPv6 since 10 years is to say, yes, we all know about IPv6, but it will never succeed, it will never happen. It's something which is which was a nice, interesting idea, but which is not relevant today. Those are today's statistics from Google in terms of traffic they receive. That's the percentage of traffic that Google receives from IPv6 network over the total number of connections they receive on their servers. So you are close to 4.5% of today's traffic, which is IPv6 based on Google server. It's very similar on Facebook, on other large sites. And some regions of the world, in particular in Asia, those stats are far higher. In Europe, you have a certain number of countries, like Switzerland, it was not far from 10% of the traffic, which is IPv6 based. Belgium, I think, is now number one. It's about 14 or 15% of the traffic in Belgium, which is IPv6 based. Most of the people, of course, do not know about it. The fact that carriers, ISP, realize that it's easier to handle, to get rid of the net in some cases and to scale up your architecture if you can use a unique and homogenized way of addressing all your nodes, all your elements in your system. You have some companies that probably some of you may know, like Free in France. Who is from France? Yes. So Free started to use IPv6 very early in the process. Most of the people didn't know about it, but it was a very efficient way for them to upgrade their box, to have a way to address directly their box from the company side. Because it's, again, very easy to have an IPv4 connection and to have your box communicating with a server. And then you wait for the box to say, oh, I'm here, now I'm ready to receive an upgrade. But then for Free, it was quite more rational to have the possibility to directly connect each and every node on the network. And to tunnel, even if they were using non-IPv4, IPv6 network, to tunnel the IPv6 channel into an IPv4 environment. There is currently, from what we see, triple convergence, clearly on IPv6, the Internet of Things, and if you have a look at the emerging standards in M2M communication, like 1M2M, lightweight M2M, they are all based on IPv6 and all referring to IPv6 as a reference addressing scheme. The current discussion, actually, on the 5G mobile network standards, are addressing also IPv6, how to increase the convergence with IPv6 addressing scheme. So there's a triple convergence between the Internet of Things, IP version 6, and the cloud computing, clearly. And that's something we see in many, many domains that probably you have noticed yourself. When we started the project, so 3 years ago, the original idea in terms of reference architecture model for the network was that probably the wide area network will not be fully IPv6. It could be a mix of IPv6 and IPv4. Today, in almost all the countries, you can have native IPv6 connectivity. It's not always the case, but in many countries. But at the time, it was worse. So we said, okay, probably we have no control. So probably in many places it will be IPv4, some places dual stack, and maybe some places we have an ISP which is dual stack, but it will tunnel and then go through an IPv4 network. So considering that this part of the network is not under our control, we cannot decide. We have to live with the internet as it is. But then in the local area network, you can clearly decide to make it fully IPv6, and that's what we did. And that's the assumption we took to design the whole architecture for IoT 6, to say, as a network manager or network owner, I can decide to move completely to IPv6. And by the way, that's something which has been done in many places, including in Africa. For instance, Free State University in Africa has decided 2 or 3 years ago, to completely switch to IPv6. They refuse any device or any application which is not IPv6 enabled. And they decide to manage the network purely as an IPv6 network. So it's not a theory, it's not a dream. And it's not a university with 100 or 200 students. It's tens of thousands of students, if I remember well. You can check the stats. But Free State University, completely and fully and exclusively IPv6. And then you have the personal area networks, the sensor networks, which generally will not be IPv6, because IPv6 will be too heavy in terms of header, in terms of... so usually what happens, you have two... We took the assumption that we would have two branches. Some of the sensors which could run 6LoWPAN, so could say a kind of compressed format of IPv6, but natively designed on IPv6. And then you have other kind of sensors, which may be non-IP, like Zigbee, KNX, Z-Wave, N-Ocean, and whatever. We started to develop different kind of use cases for the project. So I will not enter into too many details. That's just one of the first demonstrations we made between our colleagues in Korea, server in Geneva, another demonstration in Venice in Italy, and so trying to find new forms of interactions and using again IPv6 to enable interaction between sensors and tags and those kind of innovative interactions. Now I will present you a few examples of other projects in which IPv6 has been used to integrate or to interact with IoT, projects in which we have been involved. One of them is an old project which was launched quite before IoT 6. It's UDG, which intended to explore the potential of IPv6 to enable multi-protocol integration or multi-protocol interoperability. So one of the key ideas was to say, okay, we have a multitude of different communication protocols for IoT, for constrained devices. Most of them have their own addressing scheme, their own protocol pile. And what if we could use something to serve as a glue between those different islands? In other words, to try to bring the different islands together through IPv6 and to enable all kinds of interactions between those different islands. So let's imagine I have some KNX actuator on my heater, I may have some backnet controller on my HVAC system, I may have some Zigbee sensor. So how could we enable those different systems to communicate together? And for that, you need at least to be able to address them, to address those different nodes. So using IPv6 again, to map, overlay those different components and to enable cross-protocol and cross-domain interaction. And that's what we did with a control monitoring system, which has been used in other projects, including IoT 6 and other projects for research purpose. It has been used also in a website that we launched for the IPv6 Day or IPv6 Week. I think it was for the IPv6 Day, which demonstrates how you can interact with different legacy devices. So for instance, an X10 switch, a KNX valve, or a Zigbee sensor, which are non-IP compliant devices, but you can interact with them with their own IPv6 address. You can switch it on, switch it off, and so on. You just need to have an IPv6 connectivity to access it. So if you want to go on it, it's turnitivv6.com. And then if you don't have, and here we don't have an IPv6 connectivity, but then you can use a tunnel or a broker, IPv6 broker, to access it. So then you can directly interact with the device, and you have. Then another project that we launched a couple of years after is HubNet with CTI. So CTI was a coordinator, University of Patras. And the idea was to explore the potential of IPv6 with a particular focus on wireless sensor network. So how we could use it to integrate sensor, but also actuators, but in wireless networks in buildings in order to optimize, improve building requirements and building functioning. So the platform works mainly on 6LoWPAN, 6LoWAP. We had Zach Shelby, who was a partner of the project, who contributed directly to both CoAP and calling format specifications. And the project was interesting because we tried to take an end-user perspective, exploring different kind of use cases, from watering to energy monitoring to security, safety, and always trying to use the same architecture, the same platform, and trying to see how much synergies we could develop between those different use cases by using an IPv6-based architecture, or mainly 6LoWPAN-based architecture. So it led to 12 use cases, such as local adaptation to presence, electric device monitoring, always managed through this IPv6 architecture. We also, as a foundation, we have other activities. So Money International as a foundation, we have other activities with the UN system, so completely different. But we were interested to explore the possibility to use IPv6 for a large building to support delegates from developing countries. So we started to work on a concept of smart IPv6 building, where again, IPv6 would have been the glue to enable all kinds of interactions between sensors, actuators, but not only. Also interactions with the delegates, the users, with the information on the web, and really trying to use IPv6 as a kind of universal glue between entities, physical and virtual entities, whatever they are. ERIT is another project which will end in 1 month now, which is exploring the audio monitoring. Audio monitoring in smart cities and smart buildings. So you would say, but what's the relation with IPv6? It's not the focus, it was not the focus of the project. But what we had with, so exploring the potential for noise monitoring, for energy efficiency, because you can use noise, audio events to adapt the energy consumption in a building, for healthcare and so on. And then we had 2 test beds, one in Geneva, which was more focused on the indoor environment, and one in Santander's, which is with the Smart Santander testbed of Santander's, where you have thousands of sensors collecting data. And in order to integrate the 2 testbeds, again, one of the only way to do it rationally, efficiently, was to use IPv6. So we have now an interconnection, direct interconnection between the 2 testbeds, and we can, from the Geneva testbed, directly access to all the nodes through their native or virtual IPv6 address. So to manage to deploy large-scale deployment of IoT or large-scale testbed, again, IPv6 is almost a natural solution. I can have all kinds of use cases, like energy efficiency monitoring buildings, event detection, so you know that a person has fallen on the floor, so you can call an ambulance. So you can find all kinds of use cases. But again, if you want to integrate all those nodes together, you need to have a clean and efficient addressing scheme and a network protocol. Another pilot that we are just developing now with Beijing University of Post and Telecommunication in Geneva is trying to connect sensors in Geneva, in Beijing, and to find ways to have more direct interactions with web applications, with direct interactions from different web applications, Geneva, China, or other places, directly with the sensors through their IP address. And maybe I can show you. So you have, if you go on the page, if I manage to go. let's see if we can open it. But if you go on the page, you will see all kinds of data, live data from sensor on both sides and so on. So it's, again, something which was quite easier to perform with IPv6 than with, okay, sorry. Okay, let's keep it. But you have the, you can go on IPv6project.com, and then you will find it as one of the use cases or demonstrators that you can see. So in summary, IPv6 main benefits for IoT, and I would say in general for ICT application. First of all, of course, scalability is an important one. Ongoing global adoption. As I mentioned, you have seen the stats from Google, but even if we speak about IPv6 since a very long time, the rate of IPv6 users on Google side is doubling almost every 9 months, more or less. So it's an exponential process. So now currently it's about 4.5%, but probably within 1 year it will be close to 8-9%, and in 2 years it may be close to 20%. So it may grow up very quickly. End-to-end, NAT-free authentication. Security, the possibility to use IPsec and other resources which have been designed and tested and improved by the internet community. IoT compliance, as I mentioned, with 6LoWPAN, QoA, Ripple, 6TiSCH, which is an interesting development currently. Cross-domain, cross-system integration, again. Mobility. Slack, stateless address auto-configuration, which is also an important element from an industry perspective, because if you want to deploy a new device, a new component, and if each time you sell a sensor, you need someone to come to configure the address of the sensor, is just unrealistic. So the possibility to enable a kind of plug-and-play experience for the consumer is an important element. And the fact that it's fully internet and cloud compliant. So it means global integration and global interaction from anywhere in the world. Now, a few words about IoT Lab. So IoT Lab, as I mentioned, is a project which is trying to explore the potential of crowdsourcing for the Internet of Things, and how to use crowdsourcing, in particular with IoT testbeds in Europe. You have quite a number of testbeds, and I will present you a few of them, which have been developed along different waves of projects, and you have all sets of sensors in different places. And since a certain number of years, there is a growing awareness and consent to make those testbeds more sustainable, because often they are running for the time of the project, and then they are just forgotten or unplugged. And to enable more cooperation among the testbeds at the European level. So that's something which is not specific to this project. That's a general trend in the FHIR community in Europe. There is a need to better integrate the testbed, but the idea was to see how to add the crowd interactions, to extend the testbeds, and to enable new forms of experimentations, new forms of research, and including crowdsourcing-driven research. So the fundamental idea is that you have different testbeds, you have the crowd, and then on top of that, you enable to virtualize those different resources and to develop a testbed as a service, an IoT Lab testbed as a service, which then can be used by multidisciplinary experiments, including economic research, societal research, technological research, environmental research, whatever. The idea was really to provide a platform not only for engineers or ICT researchers, but for ICT researchers on other domain of research. And one of the ideas that we'll try to explore in this project is really this notion of crowdsourcing-driven research, is to enable the crowd to submit proposals for research, new ideas, new concept, or new topic to be addressed, to enable the crowd to select, to rank those ideas, to identify the most relevant one from the crowd perspective, and then to enable the researcher to start, once they've selected among the top-ranked topics to be researched by the crowd, they can select those they want to address, or they feel able to address, to start to develop something and then to test to have the feedback of the crowd, to get new suggestions on how to improve it, and in other words, to really have a closer interaction, integration between the crowd and the researcher. So as I mentioned, in terms of testbed, we have 4 testbeds, which are the initial testbed of the platform. So University of Surrey, Moda International, University of Geneva, and CTI in Patras. So briefly, Surrey is a large university campus. I don't know if Michele is already here or he will arrive not yet. But it's a very large campus with hundreds of sensors, fixed sensors, mobile sensors that are integrated together in the platform. We have a smart office testbed in Geneva that we use for more qualitative experiments, trying to find new use case, new application with all kinds of devices, sensors, actuators, using all kinds of protocols, and trying to see how we can combine them, enable all kinds of interactions. We also have a testbed which is in University for Applied Sciences, Western Switzerland in Geneva, HEPIA, where we have 2 floors which are currently being equipped and which will be used by the testbed as complementary testbeds. We have Batel, University of Geneva, which has a long experience in research in wireless sensor networks. Among others, they were part of a WiseBed project, and so we have the Batel testbed, and CTI Patras, which has also a very interesting testbed with many with Fanis, Theophanis, with their again, high expertise on wireless sensor networks, mesh networks, and IoT technologies, including energy efficiency. So together, the 4 testbeds bring not only 4 testbeds, but outcomes from different research projects. So you have, I mentioned IoT6 IRIT, HubNet, to which Unigi and CTI were key partners, IoTS, ICO, Societal, Reduce, ICT Pulse, iHub, and Smart Center. So it's really beyond those 4 partners. It's not only the 4 partners, it's access to a wider range of resources and a capitalized experience. So you have indeed a kind of triple integration with the project. On one side, you have, I would say, an integration among the different testbeds, which is a challenge per se. So for this approach, we follow mainly, I would say, large part, not 100%, but in large part, the Fed for Fire model, which is being developed currently by the Fed for Fire project. So we have a close cooperation. But so we have a multi-testbed integration, if you want. Then you have the integration process with the testbed as a service, how to make all those resources, including the crowd on the testbed, accessible to the researchers. So we have some enablers from Fed for Fire, but we need to develop a whole set of new enablers and to enable a real online experience for the researcher. It will be a kind of software as a service platform for the researchers. The possibility to log in, to access to different tools, to different enablers to perform the research, and of course the integration with the mobile phones, which is another challenge in terms of integration. With, I would say, 2 specific focus, which are important concern from the fire research community and from the European Commission currently. One of them is, of course, as soon as you work with mobile phone, smartphone, is the privacy, how to ensure that we develop something which is privacy by design, which is really not only respecting but enforcing and protecting personal data from any unwanted use by the end users. So it's really designing a whole privacy by design architecture, and that's something we are working on, in particular also with CTI and the other partners. And then another concern for many of the research projects is economic sustainability. As I mentioned, you receive funding for 3 years, you deploy your sensors, and then you say, oh, nice demonstration, we can say, congratulations, you've made a great job, a beautiful project. And then what happens, even if you don't want, you tend to switch it off. It means not that you throw away your sensors, but that you don't have anybody who has resources or salaries to maintain the infrastructure, to install the patches, to upgrade the code, and so on. So then you end up in a kind of no man's land. Okay, I have a nice test bed. What should I do with it? I don't have a budget to mobilize someone to work on it. So the idea was to see what could be the economic sustainability and the business model we could find for IoT testbed, for IoT research labs, in order to make them more sustainable. And that's why in the project, one of our partners is the University of Southampton, which comes with a really economic lens, really economic glasses, trying to see what can we do, what could you do, you as research center, to make it more sustainable. So in other words, we could say we have those integration of those 4 initial test beds. I have to say that already that was the initial plan, but I should mention that we'll have University of Luleå and some other partners of the project. So it's already moving towards more than 4 test beds. DunavNet will provide some a new branch of testbed, so it will already increase on this side. Then you have the integration with the crowds, with the smartphone. You have the testbed as a service, which will virtualize and enable and simplified and homogeneous access to all those resources. Then the interaction with the researcher, which would enable extended local experiment. It means that from the testbed, if you are based in CTI or Geneva, you can then easily use all the resources from other testbed to have more richer experiment in your testbed or from your testbed. Distributed and pervasive experiment, that's something very important, because instead of testing something in a lab and then hoping that the public will adopt it, you can directly interact with the public to get their feedback. As I mentioned, the interactions we will have here are at 2 levels. One level is the interactions with the sensors and the smartphone, so as a mobile sensor or set of sensors, if you want, with the agreement of the user, of course, the prior informed consent. And then another part will be the possibility to communicate, to discuss with the crowd, and to collect feedback from the human dimension. So there is really a part which is about crowd sensing, and the other one which is more crowdsourcing to interact with the crowd, with the people. It means that if you want to test a new thing, you can really directly have these real-time interactions with the end user, potential end users. And then crowdsourcing-driven experiment, as I mentioned, the idea the frame of the project to allocate resources to let the crowd identify ideas, identify challenges to be addressed, and then to let the crowd rank, assess those different ideas in order to pick up among the most successful ones a few use cases that we will try to implement in the frame of the project. And then the integration with Fed for Fire. So, as I mentioned, IoT Lab is really about IoT and crowdsourcing. So it means, in other words, that it's research not only for researchers, but it's really for, with, and by the crowd. And what we would like to do, we would like to collect to collect inputs from you. And we will invite you to work a little bit, to leave your laptop for, let's say, 20 minutes. I know it's hard, but I hope you will survive. And to start brainstorming on a few ideas. So we will have in 6 months' time from now, more or less, a platform which will enable any researcher, or just initial set of researchers, to make experiment with both IoT and the crowd. It can be also experiment just with the crowd using the smartphone, maybe collecting data from the sensor of the smartphone and interacting with the crowd. But it can be also a combination, for instance, in a test bed, in a test environment. You want to have users who will come in the test environment and interact with some interactions that you have set up with the physical environment. And we would like to invite you to make maybe 5 groups, more or less balanced, and we suggest 5 topics, but you can choose other topics if you want. But the 5 topics we would like to suggest, one is health of well-being, and a good example is Ebola crisis. There is currently a call for crowdsourcing the solution to address Ebola crisis, but it's a call more on good ideas. Now we'd like to invite you to reflect on how could we use a platform where you can have direct interactions through mobile phones to address this kind of problem. So it can be Ebola, you can change the focus. You can address another health topic, or you can even change completely the topic. But that's a suggestion, a first group on health issues and well-being. Another one, I think environment could be interesting, but you can choose another one if you want. Refugees and humanitarian crisis could be another topic. Smart cities with possibility to address open data, and smart home. And for that, we will have some facilitators. So we have, for health and well-being, we have Annika. If you could stand up, Annika. She is a very good moderator. She has a long experience with living labs, so it's an opportunity also for you to discuss, I'm sure it will be full of good ideas. For the environment, we have Alexandra, who is here, who could help you to, at least to, if you have questions, more details on the platform. Refugee and humanitarian action, I will take care of that. Smart city and open data, we have Joao. Joao, if you can, everybody knows you, but yes, he's there. And smart home, Theophanis, who will be part of this group, at least to help you. That means that those persons will lead the group, they will help you, they will facilitate your work. But it's really in your hands to bring ideas, visions, and others. And then what we would like from you is in about, what time is it now? 20 past 2? So let's say 20 minutes max. We would like to each group to come out with a title for your use case. How would you name it? A short description. What would you like to do? If you would have this tool, the possibility to have direct interactions with the crowd, with IoT, collecting, sensing data. What would be the required equipment? If there's something specific that you need, so it can be, but we don't need a whole dissertation, just if you identify some specific requirements or equipment that would be required. And in short, bullet points again, what would be the benefits of such an experiment if it's successful? So I invite you to make small groups. We need to distribute the group. So again, health and well-being, Annika. Those who are interested to join Annika, I invite you to go with her. Maybe you could distribute yourself. Maybe in the room we could have one table per topic. Yeah, so well-being there by Annika. And I really invite all of you, and I request that all of you take an active part in it. And even if you don't speak fluently English, just dive and suggest ideas, push for your ideas, disagree if you want, and try to end up with something bright. So, it's up to you. So Annika, who is going with Annika? Or we do the other way, I will ask. Konrad, with whom are you going? Okay. We do the other way, sorry. Who would like to start? We have an emergency group there. So let's give the priority to the emergency. Ebola crisis. In front? I think so everybody can hear you.
Okay, let's start. So I think our...
Well, I invite you to listen. I think it's very interesting because it's a collective effort. It's an opportunity to discover what each group has identified in terms of innovative ideas or use cases. So,
okay, thanks. So I think just very quickly. So our focus was how can we tackle with experiments like a platform that provides experiment capabilities like IoT labs, emergency situations such as an Ebola outbreak, and we first brainstormed of what could be some technology interventions that could be realized with mobile technology or IoT type of technology for the Ebola specific case. And we came up with 3 different types of use cases. The first one looked at basically as a form of a system that allows you to log geotag basically Ebola outbreak events, like doctors or people who are kind of like authorized to provide this information. At the same time, other people, they have a phone, doesn't have to be even a smartphone, but a phone. They have a warning system. So if they would enter an area where there has been a log recorded, they would be kind of warned, so to be more careful. So this is kind of like a very simple kind of case. I know it's not very IoTized, but you can do this with very simple technology. The second one was looking maybe at really going one level deeper into this tracking. Like you can imagine that there's a village Ebola outbreak, and you don't really know who has been in contact with whom. So the idea was maybe like an IoT patch that you can wear, that kind of like just through skin resistance is able to kind of measure that there's actually a contact taking place between people and who. So basically, just you can use the skin conductance to exchange information, and so you actually know and track who has touched whom at the end, and then at the end of the day, you can better understand what's happening. So this is like a
you can press a button and this person is
the second one, and the third one was we're really looking more like at an educational tool. Yeah? A tool that allows you, people who are actually unfamiliar with the situation, to be informed what kind of, like in a simple way, okay, there's an Ebola outbreak, what should I really do, or stuff like this. So these are like some 3 early ideas.
Very good.
Okay. Beyond that, we also looked maybe more broader on the issue of how can researchers be quickly involved in emergency or developing crisis situations, right? I think there's still a gap today in tools supporting this. So in terms of the support mechanisms and funding, like emergency travel funding or whatever, but also in terms of technology. So we're thinking of having for the IoT lab some form of technology solution that would allow researchers to participate quicker or in a faster way in emerging global research problems, right? That they can actually borrow some of their skills into that. And also maybe even citizens could maybe provide some help beyond just donations for a crisis, for instance. So if some knowledge, some resource, the capacity could be contributed quicker by a citizen. So there's a gap, it's like a broader requirement gap, but I think something that could be useful as well.
Thank you very much. Who's next? Smart City?
yes.
So
What I would ask, just a parenthesis from each group, it would be nice to have either the reporter or someone from the group to write down the conclusion of the group. The title, the description, the benefits, and the requirements. We'll try to keep it. And what we will try to do is once the platform will be ready, we'll submit these ideas into the platform. So to enable the crowd to explore your ideas and to reflect on your ideas. Yes, Joe.
So we had many different ideas, and at the beginning we were just having a brief discussion on different ones, public transportation, etc. And then we came up with an idea that we developed further, and it was on smarter parking. So what is this? I mean, we have a lot of parking use cases and applications already in market, but the difference with this one was that in the beginning you are going to the city and it is asked you a limited number of questions, and it could be where do you go, what type of car do you have, maybe one that could not is maybe not one of the first questions to be made, could be like for what time, but then the user may be not sure of what time he needs to be in that place, and are you willing to pay and how much, and this will limit the choices, and then the system would suggest a parking area, and this could also dynamically change if there's traffic or something, but then so once you get to the once you choose a parking area, you get a code, and this code you use to get into this specific area, a parking area.
Somebody else can park in the...
Exactly.
Okay, so it means there will be a kind of system to reserve, to book
Yes.
the parking.
Exactly.
Because we identified the problem that the system may say to you that this place is free,
Right.
but it's saying to 10 other persons that this
That
place
is free. Yeah.
So it's more like first come, first serve. I reserve it, and when I came, I interact with it, and it opens the gate. Some kind of device is
The other thing, so the spot where you park is maybe still away from your final destination, and you may need to take public transportation, train also. So this in this part, the crowd contributes with the measurements and is telling, okay, I'm in this bus, and so you know more or less when is the bus coming to this area. And we thought also on business models. So, 5% to the service provider. So we more or less had some ideas there.
So
And
sustainability.
another idea could be to use all this information that we gather in the platform and sell it to municipalities so that they can plan new parking areas in the city, given that this area is congestion on certain times.
Excellent.
Yeah, that was it.
Thank you very much. So, okay. Smartphone.
So we had a discussion about smart homes, and our idea was to make some project that is going to concern about smart bandwidth allocation. So we also that we have all problems here with connectivity to the internet and so on. So what our project is going to do is going to allocate the bandwidth depending on how many persons are in a certain room or so. We also know that we have quality of our servers integrated in access points and so on, routers. But maybe with our project we can avoid bottlenecking. We can avoid bottleneck. So it depends how many persons are in the room. We know that every person has a own bandwidth, no? But if there are no persons, maybe in hotel rooms on the second floor at the moment, we can transfer that bandwidth to this hall here. So we can have full availability of the internet, no, and better quality of service. And it will be fair bandwidth allocation because we are business technological people that we need it at the moment, and maybe the other people are on the beach and they are not using it. But they are left their smartphones there, they are not doing anything, so on. And the another idea which is really good, I like it, is that we can have little drones at access points that can follow people depending on how many smartphones are in one room, no? So if the crowd moves to another place, the drones goes with them, no?
That's very cool.
And the equipment that we need is smartphone with sensors. We have 3G sensors integrated and Wi-Fi and so on. And access points with routers with access points.
And a drone.
And a drone, maybe. And that's mostly it.
Excellent. Thank you very much. Then, environment.
So, the title of our project is called Community-Based Environmental Monitoring. And the issue we addressed was not a specific project, but rather how you would incentivize people to deploy monitoring sensors. It's always a difficult thing to do. We talk a lot about it, but how do you get people to do it? And the key we decided to doing that was to identify the communities of interest. So community of interest could be a local citizen committee, it could be a local housing committee. Maybe they have a problem in their area with the factory or a hospital that's giving pollution. If you can show to them the benefits of taking the sensors, they get better health, so they get improved standard of living. That's one form of incentivization. Another community could be the motorists in the city that travel a particular direction. Then you can build up over time from electronic tolling, for example, some pattern of the people who go there. You can target those people. And in this particular case, you can give some kind of incentivization through 2 days toll free per month or something. In other cases, when you want to deploy into a fixed community, you can again approach the community, but maybe reduce their local taxes if the quality of the pollution in the area comes down and the expenditure that the council has to make to control that is better. So there are many different schemes there, but it really depends. The key thing is, what is the community that we want to address? And we also extended the concept of community to take the community of providers or people who benefit from that and connecting them with the community of hackers, if I can address this crowd as such. So we have many solutions that are already there. We have many enablers. How do we bring those two together in order to make that function together, that composite system? And then I think the municipalities are key to that. But there could be other approaches. So identifying those communities and joining those communities is a key part. In terms of equipment, it could be, for example, some fixed sensors. It could be sensors we deploy on buses. It could be sensors we carry in our pockets. In the longer term, it could be sensors on the mobile platform, which gives a lot more facility then to run campaigns. But I guess that will come in the future. The benefits are Yeah, for sure. Less pollution, improved quality of living for everyone. Comes with time. Yeah.
Excellent. Thank you very much. So again, thank you to all of you for your time, for your ideas. And I think now you have, I don't know if there is a break or if, what is the plan, Alex?
I think there's the 11 break, but then I guess the rest of the days are free for your projects. I'll be around as well here. If you want to pick my brain or you're snooping around just to see how you progress.
Excellent. And so again, for each group, if you could write down a summary, and then we invite you to follow. If you want, you can follow us on Twitter to know more about the project. So it's IoT Lab, it's dash IoT Lab. And then if you want to use the platform later, or if you have any ideas, suggestions, they are very welcome. And we're here to listen to your ideas, suggestions, your needs, and to see how we can make this platform as useful as possible and as participatory as possible. Okay, thank you.